Okay, students, today we're going to be talking about simplifying radicals, and this should become a little bit of a refresher from the Pythagorean theory unit when we talked about finding perfect squares, square roots, and so on when finding distances on a coordinate plane or finding the side lengths of a square knowing the area. So, this is going to start off as a little bit of review. It is going to get more complicated. One of the things I want you to remember at the end of this is that the actual procedure of what we're going to be doing is easier than the how and the why of what it is that we're doing. So we're first going to talk about how to do this, how to do these type of procedures. So just bear with us through the notes. You can feel free to print out these notes from the Schoology folder and follow along, or you can just follow along and either take notes on a separate sheet of paper or just watch and pay attention. Okay, so let's take a look at the first section. Here we've got 3 times 3, and we know 3 times 3 is 9, which is a perfect square because two whole numbers are multiplied together to get 9. Now we've also learned that to take the square root of 9, that square root symbol is asking you a question. And the question it's asking is what number times itself is the number in the radical sign. So we know the square root of 9 is 3 because what number times itself is 9? Well, the answer is 3. So here we have the square root of 25, which hopefully you remember is a perfect square. We know what number times itself gives you 25 is 5. Now, here's where it gets a little bit more difficult. Here I have the square root of 50. Now, that is not a perfect square. So what I can do, though, is break this down into factors, and hopefully one of the factors is a perfect square. So let's think about two numbers I can multiply together to get to 50. So there's several different possibilities, but the one that sticks out is 2 times 25. Now, one of the things I like to do is when I see problems like this is I like to circle something that I know is a perfect square. So I know 25 is a perfect square, which means it gets to escape the radical sign. It gets to leave the radical sign. Unfortunately, the 2 is not a perfect square. He does not get to escape the radical sign. He's going to be trapped inside the symbol. So the square root of 25 we know is 5, so that gets to escape and go outside the symbol. But unfortunately, the square root of 2 still has to stay inside the symbol because it is not a perfect square. That is fine. That's how we leave it. This is perfectly acceptable. Take a look at the next one. Here we have the square root of 99. So again, not a perfect square, but let me think of a couple numbers that, a couple factors of 99 that can maybe break down into a perfect square. Well, let's see here. 9 times 11 is 99, and I know 9 is a perfect square. So I'm actually going to circle that because that's going to tell me it gets to escape the radical symbol. 11 is not a perfect square. I can't break down 11 into possible perfect square numbers. Therefore, it has to stay inside. So let's get 9 out of there. And when you take the square root of 9, you get 3. And like we said, that escapes the radical symbol. But 11 does not. It stays inside. So again, your final answer here would be 3 times the square root of 11. Okay. Now, here's where it starts to get a little bit more difficult because now we're going to be dealing with variables. But again, when we get done with this, you're going to see that the procedure is actually not too bad. So, first of all, we know x times x is x squared. You know, we learned that because of the properties of exponents. 1 plus 1 is 2. So, I multiplied two of the same numbers. So, let me ask you a question. What is the square root of x squared? Well, let's go back to what that radical sign is actually asking. It's asking what number times itself is the number inside the radical sign. Well, we know x times itself gets me to x squared. So the square root of x squared is x. So let's take a look at another example. X squared times x squared. You add the exponents because it's multiplication. That is x to the 4th. Well, the next problem says, well, what's the square root of x to the 4th? Well, remember, it's asking what number times itself. Well, x squared times itself is x to the 4th. So the square root of x to the 4th is x squared. Now, take a look at x to the 8th. Can anybody think of a number times itself is x to the 8th? Now, some people might say, well, if you take x to the 7th times x to the 1st, you may get x to the 8th. Yes, that's true. But these two numbers are not the same. So therefore, that is not going to be the correct answer because I need a number that is the same. Well, what about x to the 4th? Well, x to the 4th times x to the 4th is in fact x to the 8th. So x to the 4th is the answer. The square root of x to the 8th is x to the 4th. Now, here's a little shortcut. What you hopefully are beginning to notice is that if you have an even exponent, so take a look at the exponent here, it is even. When you take the square root of that, all you have to do is take this exponent, and you can see over here, divide the even exponent by 2. See what we did up here? X to the 4th divided by 2 is 2. X to the 8th divided by 2 is x to the 4th. So if I take 14 divided by 2, what do you think I end up with? Well, I'm going to end up with x to the 7th. And just to show you that that is the correct answer, well, what is x to the 7th times x to the 7th? Well, that is x to the 14th. So when you have an even exponent, just divide the even exponent by 2, and it then escapes the radical symbol. Just divide it by 2, so then outside the radical symbol will be x to the 7th here. Okay? Now, here's where it definitely gets a little bit more difficult. When we do not have an even exponent. So when you take a look at this next problem here, I've got x to the 11th. Well, there aren't two numbers that are the same that if I multiply together, I get x to the 11th. I could get things like x to the 5th times x to the 6th. That, of course, is x to the 11th, but they're not the same. I could get x to the 9th times x to the 2nd. That, of course, is x to the 11th, but they aren't the same. There aren't going to be two numbers that I multiply together that's going to give me that odd exponent. It's just not going to work. But what I can do is I can break this down into factors like I did with non-perfect squares. So what I can do is, watch what I do here, is I'm just going to break this down into two factors, one where there is an even exponent. So x to the 10th times x to the 1st. And if I'm do this out here, x to the 10th times x to the 1st, well, you add your exponents, that's going to be x to the 11th. So that is fine, that those two factors work. Now, what I want you to notice is now I've got an even exponent, which is good. It can now escape the radical sign. And we just learned 2 minutes ago that if you have an even exponent, what are you going to do to it? That's right, you're going to divide by 2. Well, what is 10 divided by 2? Well, that's going to be 5. So that gets to escape the radical symbol. Unfortunately, though, x to the 1st is stuck inside the radical symbol. It cannot leave because, again, it has an odd exponent and I can't break it down any further. So that's going to stay x to the 1st. So your final answer is x to the 4th. Oops, that should not be a 4. My bad. X to the 5th. X to the 5th times the square root of x. Okay, so let's go through this again. We're going to go through this a couple more times just to make sure that everybody's on the same page. So here I've got y to the 27th. Now again, I can't think of any two numbers that if I multiply together that are the same are going to give me y to the 27th. So I'm going to factor that, break it down into two numbers that multiply together to get to y to the 27th. Well, when I do that, I can do y to the 26th times y to the 1st. So again, notice here I've got an even exponent, which is good. And we learned to get rid of the even exponent, to get it outside, you're going to divide that exponent by 2. Well, what is 26 divided by 2? Well, that is y to the 13th. Now, what about this guy? Well, he's got an odd exponent. He is stuck, unfortunately, inside the radical sign. He cannot escape. He's got to remain. So you could write y to the 1st or not even show that y to the 1st exponent there. Okay, so this would be your final answer, and that's okay. That's as far as I can simplify. Okay, so let's take a look at z to the 19th. So again, odd exponent, the problem does not escape. Let's break it down into something, into two factors. So I know I can break that down into z to the 18th times z to the 1st. because again, we proved before, you add them up, 18 plus 1 is 19. I can factor z to the 19th into those two numbers. Now, which one can escape? Well, the one with the even exponent, z to the 18th. He gets to escape the radical symbol, and the only way he gets to escape it is if you divide it by 2. Well, 18 divided by 2 is 9, so that becomes z to the 9th. And like we've been saying, z to the 1st, unfortunately, stays inside the radical symbol. So that would be your final answer. Okay, so what this last part, part 4, we're going to put everything together, and then we're going to take a look at some more examples. Okay, so take a look at number 4. Now I've got coefficient in front of my x variable here. So the coefficient is a perfect square. So again, like we talked about earlier, I want to circle things that I can escape the radical symbol. 36 gets to escape because it's a perfect square. What two numbers come together to get to 36? Well, 6. He gets to go. Now, x to the 8th is even. He gets to leave the radical symbol. Well, how do we get a variable to leave the radical symbol? We're going to divide the exponent by 2. So divide by 2. So that's going to be x to the 4th. So that would be your final answer. The nice thing about that problem is everything gets to leave the radical symbol. Perfect square gets to escape, and the even exponent gets to escape. Therefore, we have nothing left. Now, here's the next problem. Unfortunately, we're going to run into some problems here. Because first of all, 90 is not a perfect square, and y to the 7th is not a perfect square. Well, I can break these down, like we've talked about, into numbers that are more manageable. So 90 I can break down into 9 times 10. And y to the 7th I can break it down into 2 factors. Y to the 6th times y. So which items there are perfect squares or have even exponents that can escape? Well, I'm going to circle them. So 9 is a perfect square, can escape, and something with an even exponent can escape. Unfortunately, 10 is not a perfect square and can't be broken down into any perfect squares, so it cannot escape. Y has an exponent of 1, so it cannot escape. So when I take the square root of 9, I get 3. When I take the square root of y to the 6th, remember, divide that exponent by 2, that's y to the 3rd. Then anything else that can't escape just stays inside, so that's just going to be 10y. So that would be your final answer. Okay, so let's take a look at some more examples. Take a look at page 85, and I'm going to go through some examples here with you. Okay, so let's take a look at number 11. Here I've got square root of 8 times x squared. Well, do you see anything that can escape the radical symbol right away? Yes, x squared can, because it has an even exponent. So I'm just going to quickly circle that. 8, unfortunately, is not a perfect square, so I got to break that down in the factors. And when I do that, I get square root of 2 times 4 times x squared. And 4 is now a perfect square, it can escape. X squared is a perfect square, it can escape. So the final answer here would be the square root of 4 is 2, that gets to escape. X gets to escape. And 2 remains inside. So this would be your final answer. Take a look at number 12. Now, do you see anything that gets to escape right away? Well, 81 is a perfect square. So I'm actually going to underline it because it's a little bit hard with the stylus. And since x has an even exponent, it gets to escape as well. So they're both going to escape, therefore the symbol's going to go away. So square root of 81 is 9, so that's gone. X to the 6, just divide that exponent by 2, becomes x to the 3, that's now gone. See how nothing is left inside the radical sign. Okay, just a few more here. 13, again, nice thing is that's perfect squared, and x is a 6 even exponent. They both escape. That becomes 5x to the 3rd. They're all gone from the symbol. Take a look at number 14. Okay, here's where I have to do a little bit of work because I do not have a perfect square in 8, and x to the 9th has an odd exponent. So I got to factor again. So that's going to be 2 times 4 times x to the 8th times x. So now when I look at all of these, the only numbers that are perfect squares are 4 and the variable with an even exponent. So those guys get to escape. Unfortunately, the other two guys have to stay inside the symbol. So let's just focus on what I underlined. That is going to be the square root of 4 is 2. And x to the 8th gets to escape by dividing by 2. That becomes x to the 4th times the square root of 2x. Okay? Those items that don't escape have to stay inside the symbol. Okay, moving on to 15. 15, what are some usable numbers? Well, 64 is a perfect square. X to the 9th, I got to change because it has an odd exponent. Y to the 12th, even exponent. So the two green underlined items get to escape the radical symbol. X to the 9th, I got to manipulate. So that's going to be 64. Then I'm going to break down x to the 9th into x to the 8th times x to the 1st, y to the 12th. So now I'm going to underline all the things that can escape. Well, 64 gets to go, x to the 8th gets to go, and y to the 12th. The only thing that's going to stay inside the symbol is that x to the 1st. So the square root of 64 is 8. X to the 8th gets to escape by dividing by 2. That's x to the 4th. And y to the 6th. And unfortunately, the x stays inside the symbol. Okay, let's just do one more. Let's take a look at 125b to the 15th. Now, neither one of those are perfect squares, so I got to break them down into factors. Well, 125 can be broken down to 5 times 25. B to the 15th, that's odd, so I'm going to make it b to the 14th times b to the 1st. So what items can escape? Well, 25 is perfect, and b to the 14th is even. They get to escape. Unfortunately, the 5 and the b to the 1st have to stay inside the symbol. So let's go ahead and take out the 25. The square root of 25 is 5. B to the 14th becomes b to the 7th because I divided by 2. Then what is left is 5b. Okay, so there's your final answer there. Okay, so what I want you guys to work on is just work on problem numbers 1 through 10. So just do this left side. The answer key will be provided. Check your work. And again, this is not easy. If you have any questions, we are available during office hours, or feel free to email one of us to if you have any other questions. Again, check your answers as you go just to make sure that you're doing it correctly. Okay, so just to quickly review, remember if you have a perfect square like square root of 36, okay, two numbers to multiply together get you 36 is 6. That gets to escape the radical symbol. If you have a number like the square root of like 75, it's not a perfect square, so break it down in the factors. That's 3 times 25. Okay, now the 25 is a perfect square. It gets to escape. The 3's got to stay in there. The square root of 25 is 5 times the square root of 3. Okay, for variables, if your perfect square, if your variable has an even exponent, it gets to escape by dividing by 2. So 8 divided by 2 is x to the 4th. And remember, if it escapes the radical symbol disappears. Don't need it. And if you have an odd item, an odd exponent, like x to the 13th, well, break it down so that you have an even exponent. Well, just subtract 1. So that's going to be x to the 12th times x to the 1st. This guy gets to escape. The other guy does not. So divide by 2. So 12 divided by 2 is x to the 6th. He is now outside the symbol. X to the 1st must stay. Okay? So hopefully that helps. Again, feel free to ask us any questions if you need help. Okay? Thanks.